All right, so based on what we know so far, we're going to work backwards. So as I say, there's three different colors of gumballs. Obviously red, blue, and green, you can tell. Red, blue, green. But not the same number of each color. Use the given probabilities of randomly selecting red and blue to find the missing probability of green, so if you know there's 24 gumballs in the package. Well, basically, this comes down to, we know there's 5 out of 24. 1 out of 3 is the reduced number. If we don't reduce this, we need this number here, the denominator, to be 24. So 3 times 8, 1 times 8, that's 8. So that means between red and blue, there are 13 gumballs that are red or blue. So if we just subtract 24 minus 13, that tells us there's 11 out of 24 green gumballs. Because 8 plus 5 plus 11 is 24. Okay, now we know the probability of getting a red is 1 out of 6. And the probability of getting a blue is 1 out of 2. What's the probability of green or blue? Well, remember, that just means you add them. But we still need a common denominator. So, if this is 6, this needs to be 6. So that's 3, 6. So the probability of getting a red is 1 out of 6. The probability of getting a blue is 3 out of 6. So green or blue, we add them together, that's 4 out of 6. Also known as 2/3. I'll accept either one. You don't have to reduce it. And that's 0.6 repeating, or 66.7%. All right? So we'll review. Moving on. Now we have the concept of compound events. Compound means more than one. So when you consider all the outcomes for either of two events, A and B, you form the union of A and B, shown here. When you consider only the outcomes shared by both A and B, that's the intersection. And if the union or intersection, missed one. The union or intersection of two events is called a compound event. And if there is no overlap, that means the intersection is empty. There is no intersection. Okay, so to find the probability of A or B, you must consider what outcomes, if any, are in the intersection of A and B. Two events are overlapping when they have one or more outcomes in common. That's the intersection part. The two events are disjoint or mutually exclusive when they have no outcomes in common. Okay, so this one here is disjoint or mutually exclusive. Okay, they have nothing in common. Okay, if A and B, for just two events, then the probability of A or B is the probability of A plus the probability of B minus the probability of both. If A and B are disjoint events, that's when they don't overlap at all, then the probability of A or B is, as we've been doing traditionally, just add them together. So in other words, the difference is what we're adding to the mix now is you have to take out the intersection, otherwise the intersection is counted twice. Because think about it this way, if I count A, and I figure out that, and I count B, well, I counted this section twice. That's why we do A and B and have to subtract out the intersection. Okay, card is randomly selected from a standard deck. What's probability that it is a 10 or a face card? Now, the probability of a 10, there's 4 of them out of 52. And the probability of a face card is, there's 4 kings, 4 queens, and 4 jacks. That's 12 out of 52. There is no overlap between 10 and face cards. Therefore, it's just adding them. 16 out of 52. which is 0.308 or 30.8%. Okay? And the reason we just add, like we did in the first example in the warm-up, is because there's no overlap. There's no 10 that's a face card, no face card that's a 10. Okay? Now, what if we talk about a face card or a spade? Well, let's talk about the probability of a face card. Okay? We talk about the probability of a face card being 12 out of 52. What's the probability of a spade? Looks like a 5. So, the probability of a spade, well, that's 13 out of 52. But you need to think about the probability of both. How many face cards are spades? Well, there's a jack of spades, a queen of spades, and a king of spades, so that's 3 out of 52. So we have to add these two. I don't know why I put 32. And subtract the union of both. So that's going to give me 22 out of 52. And that's 0.423 or 42.3%. All right, example 3. 200 students, 113 are varsity or on honor roll. 74 are varsity and 51 seniors who are on the honor roll. What is the probability the randomly selected senior is both a varsity and on the honor roll? Okay, so let's break this down. Okay, so let's say the probability of a senior is 74 out of 200. Okay. Then honor roll is 51 out of 200. And it says the probability of either is 113 out of 200. So that's all the information we got from here, here, and here. So now if we just fill out the formula, it'll be very easy by just substitution. So the probability of, I'm going to call this A and this B, okay? So the probability of A or B is equal to, we said, the probability of A plus the probability of B minus the probability of A and B. And that's what we're trying to find out. This is what we're trying to solve for. And we have everything else we need. A or B is 113 over 200. Probability of A is 74 over 200. Probability of B is 51 out of 200. Minus, we're just going to call this x because that's what we're trying to solve for. So now it's just back to simple algebra. 113 out of 200 equals 125 out of 200 plus both. So I mean, that was minus x. That would not make sense. And if I subtract 125, I'm going to get negative 12 out of 200 equals, negative x. Multiply both sides by negative 1. And I find out that the probability of A and B is 12 out of 200, which is the same as 6 out of 100, which is 0.06 or 6%. And that's the probability that they are both a senior and honor roll. And that's it.